Okay, in this video we're going to have a look at question 8 from the WJC additional maths paper from June 2014. And this question says, find the coordinates and nature of each of the stationary points on the curve y equals 4x cubed minus 12x plus 7, and you must show all your working. So stationary points is often a fairly standard question, and I will always start them off by working out a couple of things that I'm going to need first. So my first thing I would do is write down my y again. So 4x cubed minus 12x plus 7. Then I work out dy by dx, so I work out the derivative. So the derivative of 4x cubed is going to be 4 times the derivative of x cubed, so that's 3x squared, which is 12x squared. The derivative of negative 12x is just going to be negative 12, and the derivative of plus 7 is 0. And then finally, I'm going to work out the second derivative, so d2y by dx squared. So I'm going to differentiate this pair of terms. So 12x squared will differentiate to give me 12 lots of the derivative of x squared, so 12 lots of 2x, which is 24x, and negative 12 will differentiate to 0. So these are my important expressions. So I'm going to box them up now, ready for me to use when I need them. Okay, so now I'm going to start hitting the question. So I need to deal with stationary points, so we need to know the condition. And the main condition for a stationary point is that a curve will be stationary when dy by dx is 0. Always state this because that's the condition that we need. So then I'm going to make my substitution in. So my dy by dx is this expression that I've got over here. So 12x squared minus 12 is 0. Everything can be divided by 12 there. So x squared minus 1 equals 0. Okay, now we have two approaches. We can either add 1 to both sides, leaving us as x squared equals 1, and then square rooting, and the square root of 1 is plus or minus 1. Plus or minus 1. Now, the reason that I go a different way is because often people will forget that there's two possible roots. So this is another, this is a quadratic that you should be familiar with. This is a square term, x squared. This is a square term, 1 squared is 1, and it's a difference. So it's a difference of 2 squares. So the factorizing should be quite easy for you. You should be familiar with this. X plus 1, x minus 1 equals 0. We now have a product that gives us the answer 0. In order to do that, then one of the terms has to be 0. So either the x plus 1 is 0. So that would mean the first bracket is 0 multiplied by something, which will always give me 0. Or this second bracket, x minus 1, is 0. And that works as well, because that would be something multiplied by 0, which again would be 0. Okay, so I'm going to solve these two equations. First, I'm going to take 1 off both sides here, so negative 1. And this one I'm going to add 1 to both sides, which gives me 1. So I now have two ordinates of the stationary points, two of the x ordinates, but I want the coordinates, so I need to find the y values that match up with them. Fortunately, I can use this equation that will help me find the y values. So, x equals negative 1. My y is going to be 4 lots of negative 1 cubed minus 12 lots of negative 1 plus 7. If I tap that into my calculator, I get 15. And when x is 1, my y is going to be 4 lots of 1 cubed minus 12 lots of 1 plus 7. So go into my calculator, just change the negative ones to positive ones. That will give me negative 1. So therefore, my stationary points are, okay, negative 1, 15. So I'll put it in coordinate form, negative 1, 15, and 1, negative 1. So that's the first part of the question done. We found the coordinates, now we need to find the nature. So in order to find the nature, we look at the second derivative. What we're trying to do is to show whether they are a maximum or a minimum, or something called a point of inflection, which we don't have to worry about just yet. Now, we should know the answer before we do anything here, because we know this is a positive cubic, so y is a positive cubic. So we know that this graph will go up, down, up. So we have a maximum here. So the one that's further to the left, so that negative 115, that's going to be your maximum, and the 1, -1 will be your minimum. We just have to prove this mathematically. So if we take the point -115, and we look at d2y by dx squared at this point, so that expression is 24x. So that's 24 lots of -1, which is -24. Now, the important thing here is that you state that that's negative or less than 0. So that means that the rate of change of the gradient is a negative rate of change, which means that the gradient, as we move further and further to the right, the gradient is becoming more and more negative or less and less positive. So if we start off with something positive, as we move to the right, it becomes less and less positive until it hits 0, and then more and more negative, which gives us this maximum point. So therefore, it's a maximum. And if we look at the other point, so at 1, -1, then my second derivative will be 24 lots of 1, which is 24. Now this time that is positive, it's greater than 0, which means that the gradient, it's a positive change in gradient, which means that if it starts off with a negative, it becomes more and more positive, or less and less negative, until we get to 0, and then more and more positive, which means that you have a minimum point. So therefore, we have a minimum. And that's our answer.